Hello guys, today I'll be taking you through Java classes, methods, but then I hope that when you're watching this video, at least you know the basics of Java, like how do we declare and how do we know if something is a method or if it's not a class, but we'll be looking into that. So welcome to this video of Java, and you're taught by me, KG, obviously, and I hope we take a step back and reflect on our minds that programming is logic. So in today's video, I'd like us to talk more about logic. All right. So there's one thing that I want to always emphasize. Programming, we always want to put in mind about not repeating ourselves. And also, we want to reuse the code. If your code is clean, then it's reusable and it's going to be easy for integration purposes for future. All right. You can use it many times. So that is why we're going to be talking more about the method. So a method today, it's something that you call when you need it, right? You have a method that allows you to charge your phone. So a method is a block of code which only runs when it's called. In that method capacities, you can, I think from those that are doing different languages, they know the method as a function, right? So maybe just a way to say something that is used to perform action, right? So that is a method or function. They are used to perform action. Now, every time when we have a problem that we want to solve, we first know what is it that we want to perform, right? Okay, so I don't know what we can start with now. Okay, so now I think what we can do is to write a simple a method that we can like talk about now. So now we have this method. Let's first make a class because for every Java file we must have a class. And now we have a static or static, and gonna call it void. This one you're gonna say my first method, and it is advised to start with the small letter M. I don't know the reason. Then since we said void, it means we won't have to accept anything here. So this method, we just want to call it to do what? System.out, just to print information when we call it. You know, back in the days, our mother used to call us to say, now let us do this. We have a method that we allow our parents to use it to say, hey, wake up and go to school, or rather, hey, wash dishes, or rather, hey, do something. So anytime when your mother or when your parents notice that you have not done whatever that is assigned to you, you've never washed your dishes today, we call that method. So your mind or her mind is calling that method to say, why didn't you do what I asked you to do? So obviously, if you can do it like that. So in this method, we just say, um, did you wash dishes? That's your mom asking you that question. Hey, did you wash the dishes? So this method is called every time when your mom is upset, right? Okay. So now let us go outside of this class, outside of this method, and now call this method. Call this method. So you can call it public. This is the method that allows us to execute. This is your mom, right? So you can call it May. And here to show that this is the method that allow us to execute code and pass it arguments. Now, what do we do? Your mom is upset now. So when your mom is upset, we just do this. We just call this method. Perfect. So is there anything that is missing here? Public main file. And then is the capital letter. We need to use capital letter M. Right. Now you can do this. Do this. You run. Or you can just go here and run the file. Okay, let us see here. Did you wash the dishes? Yeah. So you didn't wash the dishes, so your mom is calling you. Did you wash the dishes? I'm trying to explain this because you can never say, or rather, she can never say, did you wash the dishes if you've washed them? I understand. So that is a quite thing. A method is called to perform a certain action. You don't just call a method. You call a method when it's needed. So now you've been called, or rather you've been called, the method has been called. Your first method has been called by your mother because you did not wash the dishes. So now, what is the other method can you write here? If you did not bath, call that method, right? Did you wash the dishes? No. We can have another method that say, why did you wash the dishes? What were you doing? Ah, blah, blah, blah. You know, African mothers, how they like to be. So that is a method. That is a method. Now, to make her to sound so bold, right? What we can do, did you wash the dishes? Because now they are reprimanding you. You keep quiet. Now we add another method. Did you wash the dishes? Did you wash? So the method is going to repeat. Did you wash the dishes? Now we can create another method just to play around with it here. To say, what kind of my second method here? Second method. I'm so fast with this keyboard. So second method can call it what? Yeah, I'm talking to you, because most of the time when when they are reprimanding us, we don't talk back, right? You say, I'm talking to you, man. Yeah, they used to say this. Yeah, I'm talking to you, man. Now let's run it. Okay, but we need to first call it as well. Okay. Now let's do it. So that's the method. We have a method that say, did you wash the dishes? Then you are quiet. Two at your corner. The second one, did you wash the dishes? The second, and then the third one is a method that says, I'm talking to you, mom. Then it's your method now. Now we have to write your method to say, I'm sorry, mom, or something like that. Then now they start complaining, you're so useless. Mean that you can write those methods. You call a method because what is the necessity of executing this method? The necessity of executing this method is because you don't respond. But if you responded, do you think this method was going to be called? No. So this method is called because you did not wash the dishes. This method is called because of you did not respond, right? So if now, hey, did you wash the dishes? Then you're quiet. It triggers another function into her mind that I'm talking to you. Now, what I wanted to emphasize is that you don't call a method because you want to call it. You call a method because a certain function, or rather, is based on a trigger. A method is called based on a trigger. So it triggered her that you did not respond to her. Now the method is called. This is a method inside one class, right? So we're just explaining method, but then when you're going further, we'll be doing different classes, two classes with different files, not in the same file, just strictly in our code. Okay, I hope you understand that part of the example. Okay, so what we can do now, I think, because we have explained that, how can you do? Okay, now let's add another method here. Oh, sorry. Okay, now we start. We want to have a convert. Did you watch the Jesus? Now let's have the third method here that we can. This method, we're going to have a different data type, because the two methods is doing by, or is what you call, through the two method are void. So we need to change that data type, right? Maybe you can call it a string to return something, right? So this is the twist. Please pay much attention. Now I want this method just to say, to call you by your name, right? So instead of yeah, let's just put out here, remove this one, make a string cap s, and here there's the third method is going to name, call you by first name. You'll see what I want to do here. Now string first name, we're going to return what? First name. Now, because we want to return first name, I want to write it in capital letters, so we just have to say to uppercase. So whatever that you write, we're going to return it into uppercase. So here, what we want to do is to say the conversation, we want our conversation to say, how can you put it? I want a name. Sam. Let's give it that Sam, right? So remember this one, just return the name. It does not print the name, right? We want a method that prints the name, right? So where can we put it? We can put it here to say, Sam, I'm talking to you. Did you watch the Jesus, Sam? Meaning that I'm going to teach you one thing that again, that I believe you do know it, is a concatenation. Do you know concatenation? When we want to join a two string, right? So here, what we can do, I want to see if we can, now let us not put it here. I want to see where we can put it. We have one that calls the name, one that calls the name. Now let us remove this one. So, okay, let's have this method. Let's print out first. Oh, now you know it must. Yeah. So print. So here we're not calling a method, we're calling my third method, and my third method would want a string. Sam. Then let's run it and see. Now it's a Sam. So to make a conversation for that, Sam, did you wash the dishes? Right? Now let's call my second method. Sam, I'm talking to you, man. Okay, now we need to add my second because my second is the one that questioning about the dishes. Oh, what's happening here? Oh, my first. My third here. All right. Then this one is my second. Oh, my first. Yes. Sam, did you watch the Jesus? Something like that. So what I'm teaching you now is some of the method will want you to give them something in order for you to, in order for them to give you the output, right? So sometimes you want a method that deletes someone into the database. You want a method that deletes a certain record, a certain field, but then which means you will need to know what number is that person first. So you say delete the person where their student number is 3, then you delete that person. That is that method that allows you to give the debt. Then that is fine. So I think we've just explained method in that regard. And how do we call method? Here we're calling a method, and what is inside the method when you call it is what? Is it parameter or argument? Because a lot of people confuses between a parameter and an argument. So a when I don't know how to explain it, but when a parameter is passed to a method, it is called an argument. So if you see now, we have what do you call this one? You see this part, Sam. Sam is an argument, but first name, a variable is a parameter. A variable is a parameter, and a value is what? An argument. I hope you get that. I hope you get that. I think what we can now focus on is classes, right? Let us now talk about the classes. Then let's see. So in terms of classes, in Java, we have something that is called Java Object Oriented Programming. They call it OOP, OOP, ne? Yeah, that which stands for Object Oriented Programming. I want you to first understand it. So, in most of the languages, basically, it is good to have your code that is clean, that is easy to execute, because it gives us a clear structure, right? And most of the time, the people do something like called DRY. So it's dry. Do not repeat yourself. necessarily. So it's a principle basically that is used about reducing the repetition of code. So if you don't want to repeat different things, so you don't want to repeat one code throughout the thing, then you're not gonna work like that. So I'm gonna talk about what is a class and what is an object, right? An object is derived from a class, right? So a class is like a blueprint. You know, a house plan. When you look at a house plan is a class. Then the house that is built based on the house plan is an object. I hope you understand that. A house that is built based on the blueprint or rather based on the house plan is an object. Meaning that if our class is a fruit, an apple is a what? Is an object. Right? For if a car is a class, then object is what? The type of a car. Volvo, Audi, Toyota, and also that. So a class is just a template for objects. Then an object is an instance of a class. All right, so I want us now to start, right? If we can start now to explain one simple thing. We did a class here, but we did not talk about the class, right? We did a class, but we did not talk about a class. So I want us now to, I think because now we are here, we'll be doing a lot of classes, right? So I want us now to click on the SRV here. So the classes that I want us to add the classes here. Okay, so let us start to add a class. Then this we're gonna call it student. Then hit enter. This is our class that is created for the student. And we know that a student has what? Has a property called what? Called a name. A student has a name. A student has an age. Right. Then this is just the blueprint. So there is no real student for this. This is just a blueprint of how we want to store our student. Now, if you want to explain what is an object, we need to go here to the main class. This is the main class. And into the main class, what we're going to be explaining is how to create an object, right? So let's just do public class main. Then into this public class main, we have this method that I like, public void main, then string of arguments. Then we need to write an object. So an object is the real thing created from the class, right? We have a class called what? Student. In Teddy, they call it package, ne? So, but then we need to have what? Student one as we instantiate that. So this is how we create an object. We have one house plan, but one house plan can build different houses, right? With same house, a typical example is an RDP house. So we have one plan for an RDP house, but we have different RDP houses that are built, or rather not even one. All right, so it means we can have another one here to say, this is what? This is an object for creating the second student, but we don't change the class. You see, this is the second student, second RDP, second that, right? So that is that, that is that, that is that. So now we want to have something here. We have managed to create an object. So this is an object of a class, right? You see how we call the class. You just mention the name of the class. This is the class, and now you're done, right? So we also want to have a method here. So let's have a method to display method, and for this method we're just going to call display, the void method that display. We don't need anything for that method. So what we'll be doing is also t parameters. We're just gonna just do this, yeah. Then what are we going to print? We're going to print the name, and here SOTP we're going to print the age. That's the sort of the basic part, right? Now, when we come here, because we have instantiated, or rather we have created the object here, now let us pass values. So student 1, I want to name the student 1 to be what? I want this person to be KG. And I want to give the age of KG to be, okay, KG is 12 years old. Right. So now I want to display the student that I created now. So this is more like a student, it's more like a form, right? We're just filling out and we're just putting you back to the database, right? Just wanted to explain it in that manner. So you say the student one that you just created, please display their details. Now let's see what's going to happen. Looking at our main program, we have created this student. But if you just say student and you want to create another student, now you need to make something that is called an array so that you can store different student into an array. But if you don't have an array, you can't create different student. But you can if you do student 1, student 2, student 3, student 4, which is so tiring because what if you have 1,000 rows, right? You can say student 1, 2, 3 up to 1,000. Just create one and put them into an array because an array is the one that helps us to logically put them, a dictionary or whatsoever. So now we've managed to create a simple part of the array, right? So you can also do, I think a typical one is to have a class of a car and a model, and you print start stop. I think that is another part. So now here, what we've been talking about into this part, what we just discussing about an object and a class. So now I want us to talk about, I think, encapsulation, right? So encapsulation, a simple way of saying it is to protect data, right? It's just to protect data. So to explain that, um, so your phone has a password. So not everyone should access your phone directly. Some of the information must be protected. That's why we have WhatsApp that is as encrypted. We have a phone unlock. We have gallery. We have bank accounts that are bank phones or other bank apps that want us to do so. So we are trying to protect that. Meaning that also in programming, we can protect a certain data, right? We can protect that other student must not see your age, but they can see your name, right? How can we protect the age? How can we protect this? Now, so instead of just allowing people to change variables directly, we just make them private. That will be good because if you see here from the student class, these are just public. These are public classes. They are public variable names. So anyone can change them carelessly. So it's a bad way of programming, meaning that for us to encapsulate, we do this. This is encapsulation. Encapsulation is just protecting the part, right? And now another part of encapsulation, what we do, I think we can also encapsulate this. Now we need to have a problem here. So right, because you see it's a one related problem. When you click there, let's hover here. It can't find it because the name is private. To see that, let us remove this. You'll see age won't have a problem because it is public. Anyone can access it. But now in this one, the name is a private. So that is encapsulation. We are protecting the variable name. Now, going back, what we need to see for this, we need to create sort of method that allow us to set the name, that allow us to get the name. So to solve all this, we fix our classes so that it can be properly organized. So we have what you call a setter, right? So let us write our setter here. You will just don't want to return anything. A setter does not return anything. So we just want to have a string. I'm just going to call it n. And now for this string, we're just going to say name is equals to n. And we're fine. Another set is to set the age, meaning that we can copy the same method, and set what? Set age instead of that. So we can say age, we call it a, sorry for bad naming there. Okay, we can just do this so that the difference will be the capital letters name age. Now we've managed to set that, but the problem is not yet solved, meaning that we need to do what? We need to talk about getters. Let us do our getters. Now, the same thing. Remember a getter, but I think it is quite explainable. A get means to return something, right? So I mean that you cannot make it void, but to make it what? To make it a string. So let us get what? Get a name. We don't need anything because you have already set up the name, meaning that this will be a parameterless thing. So just return what? Return name. Let us see if it's going to solve our problem on top. It didn't, but maybe when you call it, it might. So let us also do the same thing. Getter for what? For get age. Get age. Now here we're getting the small letter age, right? So the one that is declared outside. We're getting out when we set and when we get, we are getting, or rather we are setting the attributes or the properties. Sorry. We do any mistake here? Public int string here. Yes, age. The C age. Yes, the problem is here. We made it this. Now did we string? Yes, here. Did we? Yeah. Now we solve all the problem that we need. Now the problem is how do we then solve it, right? Because here into the main class, what are we doing here? An initialization or assignment is the same as a setter. So if you're assigning, or if you say name is equals to kg, it's the same way that you're doing what? You're setting, mean that you can call the method that set, right? Sorry, set name. Now instead of this, let's do like this. Do we need anything that we can regard here? Now let us check. I want us to expected one argument, right? Expected one argument, meaning that you can say delete from this, say here string, declare your variables here for your setters, string name is equals to kg. Now here you pass what? Name. Now that we're fine. And another part is to do what? Is to set an age. Mean that age we have to say what is equals to 12. Then instead of doing here, we just do what? Set age. Then we're done. So, but the age requires what? An argument. Now we give the argument. And now we're fine. Let us display the student information. Did we fix anything? So here, instead of this, we can just call the get. Instead of printing out here, we can call it the what? The get. But let us see if it's going to print. Let us see. It also printed the same thing. Right, perfect. But another thing that you can do, instead of calling this, because remember they are private, you don't need to call them. They are private. You can call them within your same class, right? Which is fine if you do it like this. But the more if you call the names like this into another class, then it won't be accessible. Meaning that this can only be accessed within the student class, right? So the main class cannot call their properties directly, but they can call their method to get. So the reason for this is that to avoid overriding or rather removing or certain things, right? So what we can do now here, to think about the real, if we can connect this to your real life. So you cannot open the ATM machine and take the money directly. But what we can do, we must use proper method, right? A method to calculate, a method to protect, a method to deposit, a method to withdraw, a method to check balance, right? So, something like that. Instead of changing the balance directly, we just use our method to deposit. And that's why you see those buttons to say withdraw cash. is going to call another function. It knows that when you click withdraw, it will want certain formulas, right? Perfect. Now, I hope that is quite understandable. What we want to do now is called an inheritance, right? So question, do we need this class? We can take it out and also take it out this one. So what is inheritance? Inheritance, so to speak, inheritance, just one class inherit from another class. We know inheritance when we're inheriting our father's things. If your father left you a car, then you're inheriting that. And I hope you understand that. So a child inherits from parent. I can never inherit from your father's properties. I'm not. I can never, right? So that's why we say a child inherits from the parent, meaning that whatever class that inherits, that class is a child, right? You're inheriting because you're the child or you're a child of your parents, right? So a dog is an animal, a cat is an animal. So both basically they can inherit common things, right? What we can do, I think we can, this is a typical example that are used by other programmers. We can even rename our class refractor and we call it what? Animal. AmaZulu bathi isilwane ne? Yeah, something like that. Now we can create class animal here. So all the animals can eat. So am I an animal as well? I'm not. So yeah, so here we just want systop. We just want to say the first method to say if an animal is eating, we just call it say eating. When someone is asking you what that animal is doing, you just say eating. You just call that method eating. Now let us create another class, right? The class that we're creating now, we're gonna call it a dog. This is the dog class. A dog class has been created. Now a dog class has to extend. When we want to inherit, we just write dog class extend from an animal class because there are certain things that we want from that class. Now it's going to give us an error because we are not done yet. What we have to do is say we want the dog to automatically get that method to do what? To eat, right? Automatically, if you inherit something automatically, that is yours, right? So we have a method, this animal. The animal has a method of eating. Automatically, the dog takes that as well, right? So here, what we have, I'm going to explain it also again. Maybe that's quite not understandable. A dog does what? A dog barks, and so TP. Now, what we do here, we say barking. Okay, but this is the dog. I mean, we need to put this method into a dog, not here, because not all animals bark. Right. Now we find, let us go to the main file. So in the main file, we're just going to create a public class. Public class main, and we have that our lovely method public static void main. Yes, argument. Then from here we call our dog. We don't call the animal, we call our dog. Dog, come here. So we have a new dog. Now we close this line, then we call dog. I want you to show you the method that is going to appear. The method that is going to appear is this one, a dog. When you say bark, is barking, right? Let us see what other method is available for dog. Is it that method that we don't have into the dog class comes here. So automatically when you have a dog here, when you extend, the classes or the methods that are here automatically become yours, right? Now we need to also explain generally what that means. Let us call this method and we're done. So we say barking and eating. You can create another method for a cat. Then the cat does what? Meows. A cow. A cow does what? Moo, the moo sound. So instead, we can do the animal sound, right? But every animal has a sound. I think so, right? A lion roars. Yeah, we can have that. We can add another method into the animal to say sound, right? We'll say more, meow, then the barking, or anything like that. So how do we explain this? I want us now to talk about inheritance into this particular example. So we have, I think, if we can talk into, if let's go to it. I'm gonna buy a stylus soon so that I can explain it thoroughly. Now, onto this part, we can have. How can we put this? I'm not sure if I'm going to be able to design. Where is it? Is it to draw? I want to draw. Where's the pencil? Let's just search it. Draw. Wow. Then here I can go to design. So here we have, okay, we can use these shapes. We have an animal, and the same class we have it here. Same class we have it here. Right. So now I want us to talk about another thing, right? Uh, how can we uh, should we talk about phones, right? So this is a phone. This is a class for phone, class phones, and we have different types of phone, which is iPhone and Nokia, and we have Huawei, right? So how inheritance work? So this will be what? This will be phones, right? And this will be iPhone, and this will be Huawei. And so to fix it, you just have to come here. Yeah. So how inheritance work? We look at the common features. What is a common thing that iPhone and Hawaii have, right? The common features that iPhone and Hawaii have, I think we can talk about the screen lock, right? If the common features iPhone shares is a screen lock, we just write it here and just make it 8, 9, and put it here, and we can make it small letters, lower cases. So what they share now is a screen lock. What is it that they don't share, right? It's WhatsApp. And this WhatsApp, we can talk about WhatsApp interface. The designing of the WhatsApp is quite different, or we can just say call WhatsApp, because the WhatsApp that you download for Hawaii is different for the WhatsApp that you download for an iPhone. So here we can have WhatsApp interface. So to explain this into this regard is that the main class, this is the parent, right? The parent, to put it there, we put all the common features, all the common methods, right? So in our case, if we can again give you a typical maybe example, is to talk about what? A car. Sorry, vehicle. right? So we have a vehicle. What we can actually do from this, we have a vehicle and we have all vehicles have a hooter. So I mean that here we can just say hooter, right? So maybe for this one you can talk about Polo, I mean VW, and here we can talk about Toyota. The difference is here, all the cars have engine, right? I mean that another one has to be what? Engine. But now here the difference will be what? Engine type. Because now it's different. Engine type. Now, engine type. What is the other thing? All the engines. Also, we can talk about a body type. But if you mention something that all the two classes, all the children has it in common or have them in common, then you put them in vehicle. So try to find all the methods that all classes have common methods and find in common methods, right? Methods that are not common for both classes and methods that are common. Methods that are common you put to the parents, which is what? A classifier, right? Yeah, I hope now you do understand that. I hope so. If you don't, just hit to the comment. Okay, so I think now you do understand that. Remember we talked about encapsulation, whereby we protect the data. So encapsulation is just you saying private, right? But inheritance is where you say inherit is where you put common methods into one class. What is called generalization, mean that you're just generalizing all your method into one. Okay, now let's call about a guy called polymorphism. Polymorphism, just one thing behaves differently, right? We're not going to shift from inheritance, we're just going to like talk about the same thing. So polymorphism just means that one thing behaves differently. That's what we're talking about. So animals make different sound. Cars have different body types and different engine types, right? So a dog can bark, a cat meows. So this basically they share the common sound. They share the common method, which is what? Eat or sound, right? Our car here has the common, which is hooter, but they have different one because a hooter of another vehicle or VW they will be very much different from the other one, meaning that those are the same action but different behavior. Have you heard the hoot of a truck? Clat, 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 clat. A hoot of a VW, beep. A hoot of a motorbike, tweet, something like that. Yeah, so different behavior mean that you just have one method but with different sound, right? Different behavior, a same action but different behavior. That is polymorphism. Okay, so we go back to our IntelliJ. We have what we called about an animal can do what? Animal has a sound. So we just call them sound. And now we don't want anything from it. And we just return and we call it what? Animal sound. I want you to see this. So this is the animal class. Let us go to the dog. Now, when you come to the dog, we call the same method, right? We call the same method. We can delete this one. We call the same method to say what? Sound. Call the same method sound. And what do we do? So TP, and we define the behavior of that sound, which is what? Bark. So instead of saying bark here, the previous example, we just define the sound here, and here we do the sound. So the animal has the action, but the type of an animal has the behavior. So this is the behavior, bark. Now, if we have another class, let us create another class here called a cat. Now, this cat, remember, has to extend what? Animal. When you extend an animal, mean that you're taking the method for that, right? So I'll just take void sound. Now, what do? We have the so a cat does what? Meows. How do you even write meows? So I have to be meow, meow, right? Let's do something like this, right? All the classes are sharing one action, but the behavior is different. The argument for that is different. Now let's go to our main class. So in our main class, what are we going to do? We're going to have another, delete this guy here. Now, what are we doing here? We have our cat. This is cat from SkimSum. New cat. We've created them here. So if you can say, please just tell me what is the sound of a dog. Okay, I'll tell you the sound of the dog. This is the sound of the dog. Wow, right? But what about the sound of a cat? Meow. I see that. But it does not write animal sound because now it does what? It has been overridden by two behaviors, right? If you don't put anything, if you don't give us the behavior, you just call to say, hey cat, I want to hear your sound. Then nothing happens, right? Tell me the sound of the cat. Now I'll tell you that is a what? Meow. Or the sound of the cat or the dog is what? Barks. Now you're talking, right? So that is polymorphism. I want you now to try to connect it to the things that we've been doing. The things that we've been doing. This is called inheritance, right? Inheritance because now we have a common thing, which is a sound, same action, but then different. When you talk about the behavior, we talk about polymorphism. One method is being used by different classes, but is performing different behaviors. Just one method, but it does not call the other method. It just extend the animal, right? Okay, now we can have another method. Do you see a method for pay? When we pay, right? We just call a method to pay, right? We can pay in different way. We can pay via credit card. We can pay via cash. We can pay via EFT. So that is polymorphism. Polymorphism, one thing, different action, right? Another way is just one method being used in different part. Okay. Now we're talking about someone. This person that we're going to talk about now is called abstraction. So now abstraction, if you can talk about it now, abstraction is just hiding unnecessary details, right? Hiding unnecessary detail. Let me explain it to just like a toddler. You're driving a car without knowing these things, an engine wiring, a fuel system, right? And also transmission details. I want to just start drive, stop, go, and stuff. So all those complicated things about fuel pump, all those starters, carburetor, you don't care about. As long as it can start, go back and go forward. That is part. So the complicated stuff is hidden. That is called abstraction, right? Okay. Now, let's talk about coding now. How do you even do abstraction? How do you even do the abstraction, right? So now we have this guy, and we called this guy the class, right? So let us try to do this. Let us create an app, and or you want me to first to explain it further, but I think you do understand it. So I think by definition from Google is the process of hiding certain details and showing only essential information to the users, right? I think you understand it. Yes, to the users. That is what you can talk, right? So now I want us to do abstraction. So we have what we called an abstract class and an abstract method. So the difference there is that an abstract class is just a restricted class that cannot be used to create object, right? So it's a restricted class that cannot be used to create an object. To access it, it must be inherited from another class. Do you see how we've been doing here? This is into the main. I want you to look at here. You see what if we do abstract, right? You see here, we are able to create object from the classes dog. But we cannot create an object from an animal if we use the keyword abstract. So abstract is a keyword on its own. It's the only one that is a keyword, right? And also in interface, we'll talk about that later. But an abstract is a keyword, which is a non-access identifier or rather modifier. So this is just mostly used for classes and method. If you use, because most of the time we say public, if we start with abstract, mean that you cannot create an object with it, right? Now let's talk now. Let us see what we're talking about. So we have abstract what? Animal. Oh, sorry. Abstract class. Want to create an abstract class that cannot be created as an object. What is that? An animal. An animal. And now what we can do here, we have to say, we can also create a repeat again to say public abstract. I want to show the difference. Public abstract void. We called animal sound, I think. Yeah. Then because the method, we can just leave it like this. And now, yeah, I think we find here, right? So what we can do is see we have two related problems. Now we need to be able to go to the class for the other guys. I think it's here, the dog. Now it's giving us a problem. So we need to understand what problem we're getting. It says a class dog must either be declared abstract or implemented abstract method animal sound. Let us see, because animal is a different there. Now we wrote the same method is animal sound. Okay, did we write it? Now it fixed the renaming of that method, but then how can we now fix it into this part? We made it an abstract class and an abstract method. So here, how about if we see how we can be able to write this? I know IntelliJ can help us. If we do this, it helps us by just writing that part, because we're inheriting. We just want to make it to be a public, right? To be yours. Just add the public void animal sound in order to fix the error that we managed to get, right? Now, when we get to the main file, is there anything that we need to change? No, there is nothing that we need to change rather than this guy, because now we change the naming, mean that this guy has to do also what? Change. It crashes, and how do you fix that? Read the error messages that are there. So an animal sound in cat clashes with an animal sound in the any, mean that you're trying to override the method that is there. Remember, when you extend, you inherit the method already there. So but then if you write it the way that it is, then you're not even inherited, right? Now this is how we call it that. So maybe the question will be when and why to use abstract classes and methods. So I think it will talk about the level of security. So this will be to hide certain things and only show the important details, basically. But what sort of application can we have that allows us to have abstraction? I think if you're doing forms, you would know why you need to make this effectively. Maybe you have a classes for database design, which I think we're going to talk about into the next part. So if we say this, yeah, I wanted to show you this before we can move. Let us go here. We have animal. Let us see. Let's see. Okay, so now animal is a class. This is a class. A dog is a class. A cat is a class. We have created an object for a dog. It does not crash. We have created an object for a cat. Does not crash. Let us see the error message for this. Okay, so an animal is an abstract, cannot be instantiated. So the moment your class is an abstract, you cannot instantiate it, right? But you can implement their method, which we're going to talk about now, into the interface. So put out this one. Nobody can never call an animal, but can call the methods that are. So let us do this. Delete this guy. Public still fine. If we remove this, will it still be working? It works. If you come here, remove the public, it works because we are declaring them the same way they've been declared here. Void, abstract, and all the information that has been there. Because we have extended, right? Before we have extended. Now, and I think now into the next, I believe, maybe, yeah, we can talk about interface so that we can close the chapter. So an interface is like a contract or a rule. It's like a rule. So if you can talk, let me give an example of football player, right? As a football player, you must train, you must play. Those are the rules. As a football player, you cannot play in a real match without without um without training. I also wish Paris doesn't take the league. Okay, now let's talk about I think interface, right? So for the interface, um, I think interface now talks about helping us to achieve abstraction. Remember, abstraction has a lot of, if you say abstract a class, you cannot instantiate it. So an interface is completely an abstract class that is used to group related methods within empty bodies, a definition by Google, right? So if you say in, like maybe here we say interface animal, right? We need to, maybe can just remove the void here and put it here, interface. We remove this guy here. We don't, if we do an interface class, we don't name the class. We don't say interface class, unlike abstraction class, because remember, interface is completely an abstract class. So the moment you say interface, that is and what is a thing. So that's why if you can also see here, an animal is regarded as an eye here. Or the other way of adding it, you can just come here and add an interface. Sorry, here. This is an interface. You can add it here, right? So what we can do here for the animal, instead, because we have created, remember when you create a class and you want your parent to inherit, you call the extend keyword. The reason why it's crashing now is because our class now, our animal is no longer a class, but an interface, an abstract class. An interface is an abstract class, right? So now what we have to do here, we can to change the keywords and do what? Implement. Now, there are going to be some sort of maybe errors, but let's see. If we hover here, you're going to see an animal sound in dog clashes with an animal sound in animal. Attempting to assign a weaker access privilege, package private was public. Okay, now let's see. If we add a public, it fixes everything, right? Now that's fine. So what about here? We do the same thing and we allow the cat to also implement this. And we write it what? We write public void. Now it fixes everything that is here, right? That was just a glitch. Now, is there anything that has to change here? Nothing has to change from this part. If you do, you see the same thing that we did there, we can also like do it here. So basically this worked for polymorphism, this worked for inheritance, this worked for the interface, right? So yeah, so to explain it, so if we can talk about interface is like abstract classes. Interfaces cannot be used to create object. First thing, the reason why it is. So in the example that we talked about, it is not possible to create an animal as an object here. What are we talking about here? We cannot do this. We cannot instantiate we cannot do that. We can't. We cannot do this. So interface method don't have a body. I hope you know that. Let's come here. We have nothing here. So this is an interface method. The reason why it does not have a body. So the so the body just is provided by the class that it implements. If you want to give an interface class a body, you implement it and you give it the body. That's why now here the animal sound of this interface is being given the body into the class that it implements, which is the cat and this one. So that is how it's been regarded. So on the implementation of an interface, you must override all of its method. Override all of its method. So interface method are an abstract and all of that. Yeah, I hope that. So most of the time we use interfaces to achieve security because you want to hide certain details and only show important details of an object interface into this part, right? So I think we can have multiple interfaces if we can talk about that. But now, how can you talk? How can you do it? Let's have two interfaces, right? We have a dog here. We can override this cat here and put interface, and we call it. We can say second interface. And here we can just say void first second method, right? Remember, it does not have a body, just put it like that. So what sort of, let me find an example in the browser and see if we can have something now. Can we have something? Okay, given, let's search from one of the sources there if it can give us anything. I think here will be first. Okay, so I think what I want to have two interfaces and one class. So we want to have the first interface, the first class can implement one interface, and the same thing can also be implemented there. So I want what can I have here? Okay, let's have this this interface. We have an interface that allows you to print, you know? Just because now we have a library. So let's just say printable. This is our first interface. Now when we call it, it has to print. And an interface again that does what? That save. I think that will do. And when you call it, it must do what? Do we say savable? An interface that also has to save if we do savable. So we need to remove an E here. And this interface has to what? Has to save. Now we have an interface that does what? That save, override refactor this guy and call it save, right? And this interface we need to call it the cat interface. We need to call it a printable. Perfect. Now we have what can we print and what can we save? We can do the student report. So let's just refactor this guy also, and here's student report. We can save the student report. We can do all that. So you have a student report class that we need to cancel all this. So this is how we implement. So we have a student report implements what? Let us take about one. Implements a printable. Now, so implements, this keyword means to follow the interface rules, right? Meaning that this class must print for now. We just want it to print, right? This class must print. So now let us call that method public what? Public void, and we say print. Then we say SOTP, and we say we can just write say printing student report. Now we're done. Just like that, because we have a printable, we have an interface that does what? Print, an interface that's safe, but now this has to implement that. Okay, so now what we can do is to, can you also, what if we want to have it to implement two things? All right, first let us call it here first. We already instantiated. Now what we do here, we say for the report, please, I want you to give me the report, print the report. So if I print the report, I need to find certain information. Student report has been printed. This is what you're going to do. When you click that button, it must print. When you click that information, it must print. Then I want the same student report to also do what? To save. To save. So, but then what happens when I want to implement two interfaces? You just put a comma and you do it. But now you need to also put the method that save comes from. So same method, save, then you do it, you don't pass, right? We say so TP, and we're out saving student report. Right, so now we can also come to the student report or the main where our file is and say report, do what? Save. After you print, please save, or rather save and print. So printing the student report, and the student report has been saved. Right, now that is that. I hope you guys understand that. Right, I hope you do understand that. So we have printed the student, and now we have showed how the interface work and how that works. So we have also managed to put it into a, so what one typical example that you can talk about is one thing: a smartphone can call, can take pictures, can connect to internet, meaning that it follows many rules, or rather we can say abilities, right? This is also regarded as a what? As an interface, right? So we have interface one, maybe another one that may be playable, an interface that allows you to play music, an interface that also allow you to download, right? Then your class will be what? A music, right? Will be a music app, right? I think that will be also be doable. Okay. So I need to ask you a question. This is a question that I need to ask you. Can a Java class implement multiple interface? Can interface? So if you answer that, you can give me just to justify your reason, right? Yeah, and how do we do that? Okay, right. So I think if you use me, you must implement my method. That is a simple way of talking about interfaces. If you're using me, you must use everything that you're doing. It's like if you use me, you must pay me. That's an interface. I don't work for free. So, guys, I think this is the end of this class, and this whereby we're talking about a interfaces and that, right? So we need to know when you're using it and when you are not using it. I think more of the application can be used when we are dealing with forms, or rather when you're dealing with huge application, right? So I think maybe in the next one we can talk about arrays, combination of this and array. Now that is fine as well. So thank you for tuning in, and you can give me a thumbs up if you enjoyed the video. Thank you.